The recording and unfreeze the screen so you can see it. Right. So hello again and welcome to week 5. All 16 of you who turned up. I think we can sort of blame the weather today, so I'm hoping that the rest of you will be watching this on video, assuming the video works. Hello to those of you at home. So we've got 4 weeks behind us now, which means we're a third of the way through the course. And I thought it might be useful just to kind of recap what we've done. Week 1 was really just, historical background and a bit of Moore's Law just to get the ball rolling. Week 2 was JavaScript, because you need to learn some programming to be able to program games. Week 3, mostly rendering stuff, where you learn how to use Canvas and draw stuff. And then last week, week 4, there were a couple of things. There was the input handling stuff, so that you could actually create, interactive things that respond to your movements. And we spoke a bit about the general business of simulation updates as to how you would get like a game clock running, which we talked about but didn't quite actually do. Now, you take those elements that I've described and put them together, that does define what I said was the main loop. You can gather inputs, update the simulation, draw stuff. We can sort of do all that now. And once you can do that, that's just about enough to create a minimal game. So let's make a game. Let's do it. Let's make PONG. Here we go. So I'm just going to go through this step by step and show you how to do it, and hopefully you can follow along. So the first thing we're going to do is create a paddle, the kind of basic starting point of PONG. So we just need to create a paddle object, give it a position and size, let it be able to draw itself. And in order to do this, I've created a bunch of fiddles that let you do it, and I'm just going to walk you through them. So here is the first one. Can you see that okay? I realise the text is a little bit small, but I can't really make it any bigger, otherwise you won't be able to see the output. But is it okay? Sort of, right. Okay, so here's what we're starting with. You've seen this stuff before. This is just my usual boilerplate things where I've got the canvas and the context. That's all fine. Let's come down to the actual paddle. So what I've done here is I've created a paddle object. At this stage, we're going to make it a global object, which I've hinted at before is not ideal. Global objects are a little bit unattractive, but they're also simple. So for the sake of simplicity right now, we'll do it this way. But in order to draw attention to the fact that it's global, I've got my G prefix on it. And I create it and I give it some properties. So giving it CX, CY, half width, half height. Maybe worth saying something about the choices here and the names as well. I haven't just done X and Y, which is what you might think is the natural thing. I've done CX and CY, the C standing for center. And that's to remind me that I've decided to make the paddle track its center coordinates. Now that's not entirely obvious. You might think the obvious thing to do would be use like the top left coordinates, just the way the rectangle drawing routines work. They have a top left, bottom right arrangement. But it turns out when you get deeper into things and you start thinking about moving it around and so on, that if you started with the top left, then all the code for moving things to the left and up would be kind of easy, but moving to the right and down, you'd have to add offsets to everything. But if you make it based on the center, you have symmetry. So the left and right cases and the top and bottom cases come out very, very similarly. So I thought that was worth doing. And because of that, because I've based it on the center, I must say, is there something funny happening? Because you are laughing quite a lot.
Sorry, I was working with other people.
What are they doing? Are they being funny or are they just irritating you?
Well, I don't know what they're doing.
Okay. All right. Just wanted to check in case there was some humour that I was unaware of. So in addition to using the center positions, I've also used, instead of the width and the height, which is what you might expect, I'm actually specifying the half width and the half height, because if you start from the center, that's what you actually end up doing. You move it by half the width and up by half the height. So it's a bit like a radius. Radius is a half diameter. It just turns out that if I'm going to do it this way, this seems to be slightly neater. So that's the way I did it. So you create a paddle, easy. And now we want to give it some methods. Well, I'm only going to give it one method to start with, and that's a render method. And remember, JavaScript is easy. The way you add methods to an object is you just give it a new member that happens to be a function. And if it's a function, it's a method. So I say I want a render member, which is going to be a function that takes in a context and draws a filled rectangle. Now, as I explained above, because I'm using center coordinates, in order to draw the rectangle, I actually have to do a little bit of work. I have to offset the center X, I have to pull it back by the half width, and pull back the Y by the half height. And then I have to double these to make them the full width and the full height for drawing the rectangle. So that's a little bit ugly in a way, but it turns out that by taking this approach, the render routine has got a little bit of ugliness, but the subsequent update logic is a lot cleaner looking than it would otherwise be. So I decided this was the reasonable trade-off. Okay, so we've got our object and it's got a method. We want to have some kind of render simulation function for our main loop to call, and here it is, and it just simply renders the paddle because that's all we've got. And then you want to kind of make something happen, so you want to kind of initialize the system. And for now, I've said you initialize it just by doing the rendering part. So we don't even have a main loop yet. We're just trying to say render the paddle, and it should go up here and it should draw a nice little rectangle. And as you can see, we have a lovely little, oh, wait a minute, why didn't it work? Well, how embarrassing. Now this is the kind of thing you might notice happens when you're working on JavaScript, that you type something in, it should work, it doesn't seem to work, what do? Just thought I would mention to you that you have some things you can check. One is that JS Fiddle itself now has a console thing down here, which is just the same as the developer tools console. It's a similar version of it, and you can actually see it's got a little, well, maybe you can't, but it's got a little circle with a 1 next to it. That's an error indicator. If I click that, it just brings up the console and shows me what the error messages are. Turns out we've got a little error message. Uncaught reference error, stop is not defined, which is maybe not terribly clear to you, but I understand it. What it's doing is it's warning me about this thing up here, where I put in a deliberate error at the top of the file just so that it wouldn't run before I wanted it to. You can also see that the JS hint thing has identified this as a syntax error. So if you scroll through your code, you can sometimes see these little warnings. Or so you can bring up the console and try and look for error messages there, just to remind you that that's a thing you can do if your code doesn't seem to be working. It's often the case that you've got like a typo that's creating one of these reference errors or some silly mistake, and that's where to look for your diagnostics. So having identified this little bug, I can comment out the error, and these things clear up now. And then if I run it, we might actually see the paddle. Hooray! A triumph. Please hold your applause till the end. Okay, so that was step 0. Step 1, we want to make this paddle drivable so that we can, play with it. So we want it to be event-driven. So this is very similar to last week's homework. This is just adding an event handler that can move this object, update its position, and redraw it. Okay, so I'll show you that over here. Right, so this is step 1. So as I said, it's just what I said on the slide, adding an input handler. So we'll go down here, and now we've got some new code, very similar to what you saw in the lectures last week and your own homework. I'm going to create my global keys array so I can keep track of what keys are being pressed. I know I'm going to be interested in W and S because I'm going to use those for up and down on the paddle. Now, my preferred way of getting the key codes, it turns out that for ordinary alphanumeric characters, if you simply take the uppercase string, the uppercase ASCII string, and you say get character code at position 0, which is get the character code of this thing, that will turn out to be the correct key code for the corresponding key. That's just the way it is. So I always create these little, really technically should be a constant, key underbar W, key underbar S, so I can then talk about these keys without having to type in any like obscure magic numbers that nobody knows what they mean. These are sort of self-describing now. They're just the key codes. And we're going to have a key down handler, which, as we've already covered, the main thing it does is when you press the key down, it sets the appropriate member in the keys array so that we know that that key is indeed down. True means it's pressed. And then we process the keys. And this is the important distinction that was relevant to the homework as well, where there's one part of this which is tracking the key events, because that's when things change, and then there's looking at the resulting array to see, but now which keys happen to be down, because you'll only ever get told one key event at a time, but you might have multiple key presses at a time. For example, you could be, moving and scaling and rotating, and you want to process them all, even though you're only being told about one of them. So this is what you do. You just write a bunch of if statements to see if, in this case, is the W key pressed, and if so, I take the Y coordinate of the paddle and I subtract 5 from it to make it go up, or if it was the S key, I add 5 to it and make it go down. There's actually a slight, this thing that I've done here, there's a slight ugliness in it, and I've got an else statement in it, which isn't really needed, and in fact, it's actually a bad idea. Because I've got the else statement in it, it will only process either W or S. So if I happen to have them both pressed, what will happen? The W will take precedence. So if you hold down both keys, it will move up. And it's like, why should there be that kind of unfair bias in favour of up? So really, I should just have written 2 if statements here. And if I'd done that, what would have happened if I'd pressed W and S at the same time?
It would stay still.
It would stay still. They would both would have effect, and they'd cancel each other out. And that's actually what you would want. So that's ideally what we're doing best here. But that's close enough. So that's key down, key up. You just set the flag to false, of course. And this is just the standard stuff to install those event handlers. The paddle is as before. And there's a little bit more to do down here, but that's basically the beginning of an event system. So hopefully if I go over here and I now press W and S, I'll be able to move the paddle up and down. Oh dear, once again, how embarrassing, it's not working. So what have I done wrong this time? I mean, I've got my event handler, I'm processing W, I'm saying change the Y value, and I'm pressing W here. I'm pressing it really hard, and it doesn't seem to make any difference. I'm not redrawing, right? Because again, the machine isn't psychic, it doesn't know that you want to redraw it, even though it's kind of very obvious to us. We have to redraw it. I, in fact, anticipated this, as you may have noticed, so I have to redraw it, and I think I called the redraw routine, render simulation. So you need to put that in. And again, you have to do this in your homework as well, that your event handler could process the logic, but if it doesn't redraw things, you don't see nothing. Okay, so if I put that in and I run it, why has it got a little warning on there? It was global context, isn't it? Yeah, because of the global variable. There we go. That's a nice little helper there. Okay, and I'll just click the run explicitly so people on the video can see that that's what I'm doing, although I can also press Control-Enter to do the same thing. But I run this piece of code, and now I've got an event handler, and I've got a renderer, so all is well, and I'll be able to move up and down, and it'll look great, won't it? And of course, what's happening there is I've got a trail for free. Hooray! Why have I got a trail? Because I didn't clear the damn thing. So again, you sort of think, oh yeah, you should clear the screen every time you draw, but it doesn't have to do that, and it doesn't do it automatically. You have to tell it to. So, oh look, it's almost as if I knew. Down here in the render simulation routine, you want to clear the canvas before you draw, otherwise you'll get a free trail. And of course, the homework's got the little trick about sometimes you want the trail and sometimes you don't, and you have to do some cleverness. But basically, this is what we want. In your own time. Right, so now it might actually work. Let's try it. Press S. Way! Press W. Way! It will, of course, go off the top of the screen because we didn't tell it to prevent that either, but that's okay. One thing at a time. Right, well, that's something. Let's move on to step 2. And again, the slide just to show the corresponding text. So, so what happened there is we were moving the paddle, and it worked kind of okay. And even when I held the key down, it kept moving. But that was just taking advantage of the key auto repeat, the same thing as we saw last week, where the first time you press the key, it moves, and then if you keep it held down after a certain amount of time, the system starts generating key repeat events, and then it kind of moves again. But that's a bit ugly because it means that the first move happens as soon as you press the key, and then you have to kind of wait a bit for the key repeat to kick in, and then you get the subsequent movement, so it's not smooth. And there's another problem with it, is that that key repeat event is like an operating system preference, and you can change it. Some people like to make it repeat faster than others. So if you actually did this in your game logic, people would be able to cheat in your game by changing the key repeat rate, they could make their player like move faster than other people by having a lower key repeat rate. So it's totally terrible to base game logic on this. So we don't want to do that. We actually want the paddle to be based on a time-based loop, which is what we discussed in the kind of simulation update lectures. And the way you do this is you have to tell JavaScript that you want a time event that acts as like a heartbeat, and then you make all the logic run on the back of that. So we'll see how that works. That actually has some nice effects. Once you add the time event, it means that you can clean some things up as well. It means that the key handling events don't have the logic to process the keys anymore, because we're going to process the keys based on the time loop instead, which means that the key handlers just become key handlers. They simplify down to this now, which is nice. And what we end up with is an actual main loop now. So this is instead of the game just being event driven, a bit like a super hot, that things only move when you move. Now we have a main loop that kind of runs with a life of its own. So gather inputs, we actually don't need that right now. Update simulation render. So let's go to the update part of it, and you'll see that what we do in update simulation is, I think, the natural thing. You take the only object that we've got worth caring about, the paddle, and we tell it to update itself. And what's happening now is that the update logic of the paddle, which is going to be called regularly by a timer, that's the thing that moves the paddle. And this is much better than the previous thing. The previous thing, we had a routine that was a key handling routine that also moved objects in the game. So it was doing too many things. It wasn't just an event handler, it was an event handler and a bunch of game logic, and it was kind of in the wrong place. So we'll put it now in the right place, which simply involves taking the paddle object that we already had. It already had a render, and now we add an update, and this is like what you really need to do proper simulations. So now we get an update function, and it includes the logic that looks at the keys array and works out whether to move it up or down. And that's nice and simple. And the thing that makes all this work is down at the bottom here, we do a thing called set interval. How many of you know about set interval? Got one or two hands, not many, okay. So it's a standard JavaScript thing that you use to say you want a time event to occur. And what you do is you tell it how frequently you want it to occur, and you tell it what the handler function is for that timer event. So just in the same way you have a handler for a key press, you have a handler for the clock going off. So I've told it that I want to call this main iter thing, which is my main loop up here, and I want to call that at an interval of 16.666 milliseconds. Why did I pick 16.666 milliseconds?
60 frames per second.
Because it's 60 frames a second, right? It's the standard one. You take 1,000 divided by 60. It's that.
Might be optimistic for the projector.
Yes, that's. You mean people being able to read it or being able to see it? Are you talking about the frame rate of the projector?
Yeah.
Yeah. I suspect it probably actually is running at 60, but I haven't been able to check that yet. But that will become relevant later. But anyway, so this is the basic infrastructure now. Okay, we say I want a little thing to go off every 16 milliseconds. And that will update things, and then we'll draw them, and this will create something that is still reactive to the user, but is hopefully smoother. It doesn't have that dependency on the key repeat rate and so on. So if it works, this will now move, and it will actually be more fluid than it was. This is when it moves, it has a nice linear speed, and it maintains it. Now, incidentally, when I talk about things looking smooth, that may not come across if you're watching the video. The video is being recorded at 15 FPS, so when I'm looking at things that are higher fidelity than that, 60 FPS, you won't necessarily see them. That will cause some problems in this lecture, and maybe the one on Wednesday, where I'm talking about things that are like flickering on the screen, and they may or may not appear to be flickering on the video, because they're not going to be exactly the same rate. But we'll get to that later. All right, so we've now got time-based events, so that's a nice step forward. And this is the first time we've done this, right? I spoke last week about how to do it, but we didn't actually do it because previously, when you're moving the smiley, it was all event-driven. But this is now partly, event-mediated, but it's driven by a timer clock now, which is good. So now that we've got a timer, we can put a ball in, which we couldn't do before, right? We wouldn't really have had a way to make a ball be part of the game because we wouldn't have any time mechanism to make the ball move. Again, the ball would, only move when you explicitly pressed keys or something, which wouldn't be good. But we can do it now that we've got a proper clock. So this is a success. This is the first time I've actually got someone sleeping in the lecture. But, you know, you all work very hard, and I understand it's difficult being a student, and it was probably a rough night on the booze. So there we go. We'll just let them rest. Okay, ball. Key handling routine stays the same. Paddle stays the same. So this is just as it was. But now I'm going to create a ball as well. So we get a new object, and it's going to be a bit like the paddle, only not. So it's going to be gball. It's actually fairly obvious that for a ball, you do want to use the center coordinates. It's very natural to think about the center of a circular object. So it's got an x and a y and a radius. I'm also going to give it a velocity, which is in two parts, the horizontal x component and the vertical y component. And I just put those in as properties of the ball. And then I give it an update and a render routine. The render routine, very simple, kind of obvious. It just draws a circle. Nothing fancier than that just now. The update routine is also very simple, and is really just, it's kind of doing one thing. It does it twice because of reasons. But basically what I'm doing is I'm computing the next position that the ball ought to have, which is just its current position plus its velocity. Now, if you were really paying attention last week, you'll know that it should really be plus velocity times time, right? But I'm deliberately not doing that part yet. What I've done here is when I've said the set interval thing is going to run every 16 milliseconds, I'm trusting that that's going to work. I'm trusting that we'll always be able to hit our 60 FPS target. So I can basically just assume that the delta time is always this, this nominal amount, which I'll just treat as 1 for the purposes of these calculations. So this is me kind of assuming using a fixed delta and assuming a fixed frame rate. I'm going to improve that on Wednesday. I'm going to show you how to do the variable frame rate, but the easiest thing is to keep it constant for now. So very simply, when the ball gets updated, it just moves a little bit, and that's really almost all that's needed here. To bring it to life, you actually have to call this update routine somewhere, of course, but that's easy. It's kind of, I hope it's kind of logically obvious to you where I put that. We've got a routine called update simulation, and previously it was updating the paddle. Well, now I just make it update the ball and the paddle. And likewise, the render routine needs to draw the ball and the paddle. And that's it. So I've just added an extra element to both of these functions, and that should be enough to get this thing going. So if I just go up here and remove my deliberate error, we should hopefully see an actually moving ball. Yay! It's a triumph. We'll see it again. It was so good. Wow! Right. So this is the first time we've done. This is a breakthrough. Right. This is an object moving under its own steam, as it were, controlled by a timer, which is like a key element of making a real-time game. So that's great. Yep. So here we are. We've got a simulation. Now, yes, well, so we've got a ball, but it wasn't bouncing. It just moved, and then it fell off the screen and has just kept moving, and we'll just keep going for a long, long time. What you obviously want in Pong, really, is for the ball to bounce when it hits the borders of the game, or, well, at least when it hits the top and bottom, once it should bounce. What we're going to do is we're going to make it bounce off the top and bottom, and if it falls off the left or the right, we're going to reset it, because that's like scoring a goal in Pong. So in order to do that, I have to make the ball update logic a bit more complicated than it was. Up until now, the ball update logic just moved it, but we need to move it and do some kind of approximation to a collision check or something, right? Now you might want to think ahead about how you do this. How do you make a ball if the ball hits let's say the bottom of the screen and bounces?
The velocity?
Yes. So generally what happens is if you've got an object and it bounces off something else, it's a bit like, when light rays bounce off a mirror or something. It's angle of incidence equals angle of reflection, and you can compute normals and you can work out how to flip them and do the geometry. That's actually, a little bit non-trivial, but it turns out it gets very simple if the thing that you're hitting is either perfectly horizontal or perfectly vertical. In the case of a perfectly horizontal obstacle, if you're coming down like this and you hit it, and you're doing the kind of mirrored bounce, all that's happening is that the y part of the velocity gets negated and the x part stays the same. So the horizontal component keeps going, so it keeps moving the direction it's moving, but it just flips in one axis. So all you need to do is check whether that case has occurred. Have you fallen off the screen? And if you have, you do the flip. So we just go down to the ball update routine, and you see me doing it. So I start by doing this thing where I work out the next x and y position, which is where the ball would go if there wasn't any problem, if everything was just going normally. And then I check for the special stuff. So the special stuff is either falling off the top or the bottom edge of the screen. So you fall off the top edge of the screen if your next y coordinate would have been less than 0. And you fall off the bottom if it would have been larger than the height of the canvas, which is this thing here. And 400 happens to be what the canvas height will be. So I detect that case. Just now, of course, I detect that case, then I don't do anything. But if I put in the thing I should do, and I negate the velocity, which I'm doing by multiplying itself by -1, which is the easy way to negate it, then we can flip the y velocity. I also want to care about the falling off the left and right cases, which I'm handling slightly differently. As I said, that's the equivalent of scoring a goal in Pong. What I want to do there is, if you score, I want it to kind of go off the screen a little bit, just so there's a sense of it kind of, the ball kind of went off the game grid for a little while, by some amount called margin, which I've just made 4 times the radius of the ball, just because it looked okay. And I'll do equivalent logic here for the x. So if the next x position is less than the negative margin, that means we fell off the left side, that's your left, right? Or if it's greater than the width plus the margin, it fell off the right. And in that case, instead of making it bounce, we just kind of throw the ball back into play by resetting it. So I've got a little function called reset that simply does this. It just puts the ball back somewhere in the middle of the screen with a new velocity. So you put those things together, and what's happening in here is that you might change the y velocity while you're going through here, and you might do this reset stuff that changes everything. So having done that, you then compute the true next position, which is just by taking your previous position and adding the velocity components. So if I do that, we get this, hooray! So again, if I start it, you'll see that the ball moves, bounces, and then when it falls off the world, it gets reset and gets kind of thrown back into the world, at which point it just keeps being thrown into the world. And this, of course, at this point, if you were optimistic, you would think, great, I'll move the paddle down and we'll bounce it off the paddle, which of course won't work because you haven't written that yet, but maybe that's what we should do next. Right, so what we'd like to do is have it so that when the ball hits the paddle, it bounces off that, which would be, what would be the, someone other than the person who usually answers, tell me what should I do to the ball when I've detected that it hits the paddle? What would be the central piece of logic that needs to be run?
Reverse the x velocity.
Reverse the x velocity. How many of you knew that and just didn't want to say it? Don't be scared to say it. It's good for me to know that you're following, right? And I think you are mostly, but it's helpful if I know that you're with me. And don't worry about making mistakes. Some of these questions, they're kind of designed to be slightly non-intuitive, but others are just easy. So feel free to answer questions. It's part of the process. Anyway, yes. So when we detect a collision, we'd want to negate the x velocity. But how do we detect the collision itself? Well, if you want to do it properly, it's actually a little bit complicated because you need to do like a geometric overlap between a circle and a rectangle. And in fact, it's actually a little bit worse than that. If you're being strict about it, it's actually the path that the circle takes from one frame to the next, which is what we call a lozenge shape, like a sausage shape that's kind of like a circle but stretched a little bit. So you need to take that shape, which is rounded and at an angle, and overlap it with a rectangle.
Can't you just have the right-hand side of the rectangle just be a line if it hasn't that then?
Well, that's a good anticipation. So as I was saying, if you do it strictly, you need to do this kind of geometric test, which is a little bit elaborate, and it turns out, it would kind of take too long. And this was a useful place in which to let you know that often in games we take shortcuts for things like this. That often if you've got a problem like this, it's a little bit gnarly. One thing to do is to say, look, is there a simplified version of this problem that's like close enough that would probably look okay? Because people don't have absolutely, perfect fidelity in observing things like this. So the idea is, can we make it a bit simpler? And we've got one suggestion here how to make it simpler. Does anyone think of another one? What else could I do to make it a little bit easier than doing a full circle to rectangle check? What can I do to make my life easier?
Could you make that a hitbox or something?
A hitbox, right. Yeah, so a hitbox is a thing where instead of using the real shape of an object, you put like a simplified boundary around it that's easier to work with. So in this case, I could, instead of thinking of the ball as a circle, I could put like a little square around it and just treat the ball as if it was a square. So now it would be a square against a rectangle, which is really just a rectangle against a rectangle. It wouldn't be perfect because, balls are rounded and squares aren't, but this is often done in games. So what I could do here is I could do a collision check between two rectangles. And I could actually do something even simpler, which is what I'm going to do. I'm going to pretend that the paddle is just a line, which of course it's not, but to a first approximation, it's a slightly fat line, right? So if I just pretended it was a line, then I'd be doing like a circle line check, and all I really need to do there is work out whether the circle has kind of moved from being on one side of the line to the other, and if it has, that counts as a hit. So that's the way I'm going to do it. Now, it is a simplification. It's not absolutely correct, but it's quite easy to do, and it's probably good enough. So we're going to try it and see if it works. Okay, so we're going to do circle against line. So again, where am I going to put this code? Because this code is getting, it's not big, but it's got multiple functions in it. Where do we even look? Which function should I be looking at to implement this collision behavior? Someone who hasn't already answered the question. Where are we looking? Okay, update simulation, you said. So that's like nearly true, but be more specific. Because if we go, well, let's go and look at update simulation. In fact, update simulation, there it is. So update, exactly, it's just the ball update, right? This is actually conceptually quite simple, and I want you to realise this is part of why object orientation is supposed to be good for this kind of thing, because you say, well, we're dealing with a whole bunch of little sub-problems. This sub-problem is about how the ball moves, making it glide off the paddle, and the things that the ball does should be in the ball's update routine. That's where they go. Now, actually, you can have a debate here, because you can when a collision occurs, you can always argue that, well, it could be the other one's colliding as well, right? The paddle is colliding at the same time as the ball is. So in theory, you could do it in the paddle, but it feels like the ball seems like the better choice right now, because the ball was the active agent. The ball's the thing that's moving, and it's the one that's going to have to do the bounce if something happens. So I kind of feel like, yeah, the ball update routine should be responsible for this. So we scroll up until we find the ball update routine. Here it is. And we make it a little bit more complicated. So one of the things that you often do when you're doing collision checks is you start by remembering the previous position of the object. That's because if you get into a kind of sticky situation with a collision, one of the things you can do is you can just say, well, go back to the previous position. So it's often useful to know what that position was. Having done that, we then compute what would be the next position under normal circumstances, where you just add the velocities. And now we look for the paddle. So what I've done is I've said, I'm going to pretend that the paddle is just a line. So it's just going to be like a thin vertical line. And I'm going to make that line be down the middle of the paddle, because that seems like, again, symmetrically fair to do it that way. You might want to say make it be the right edge, but I'm going to pick the middle for symmetry. So I just take the center coordinates, center x coordinate of the paddle, and I'm going to just rename that to paddle edge x. I'm not saving any typing by doing this. It's not a small variable name or anything, but it's more explicit. It reminds me of what I'm doing. So it's the paddle's edge x. And this one I'm going to do to save typing. I don't want to have to type this dot radius several times over, just one line after the other. I'm just going to abbreviate it to R. Perfectly legitimate to use very small variable names for like throwaway purposes like this, even though you wouldn't, you would want the proper object to have like a good name, but it's okay to abbreviate it if you're going to be typing it many times. And then I do the basic check. So the basic check here is what I'm trying to work out is has the ball kind of crossed from being on the right of the paddle to being on the left of the paddle. So that will happen if the next position of the paddle has gone beyond the x coordinate of the paddle itself, and previously it was on the other side. And it just turns out this is the logic for that. So you take the next x position minus r, which is going to be, that's the left edge of the future position of the ball. So that's like where it would be going under normal circumstances. And if that is less than the paddle edge x, that means we've crossed over the paddle. But it's not enough to just check for that, because you might be on the left side of the paddle because you already were on the left side. It's important to understand that the collision occurs when you go from being on the right to being on the left. So I need to check for both things. I need to check, is my future position on the left of the paddle, and was my previous position on the right of the paddle, which is greater than or equal to. So you can kind of think of this a bit like a sandwich, where you've got next position of the ball here, and the paddle in the middle, and the previous position on the right. So it's kind of like, if that inequality changes, it means you've gone from being on the right to the left, and that's the condition. But it's not enough to just know that you've crossed from the right to the left, because we're crossing from the right to the left right now. When the ball gets down here, that's crossing from the right to the left, but it's not hitting the paddle because it's not hitting the Y part of the paddle. So you have to check for that as well. So again, I just pull out the center position of the Y center position of the paddle and the half height value, and I have to calculate this bit here. So this is just checking whether the Y position of the paddle, sorry, the Y position of the ball, the Y position plus R, so that's the bottom of the ball. So has the bottom of the ball gone beyond the top of the paddle? It's basically checking for, is the ball below here? And this one down here checks, is the ball above here? And if it's below here and above here, then that means it's somewhere within the height of the paddle. And if all those things apply, if we've gone from the right side to the left side, and if we're somewhere between the top and the bottom, then that's a hit. And if it's a hit, you flip the x velocity. So that should probably work. Way! Okay, so that works just fine. Even though it's a bit crude, if you look very carefully, you'll see that the ball doesn't really collide until we're actually a little bit into the paddle. It turns out your eye doesn't really notice that very much. It looks okay given the sizes of these things. There are also some slight imprecisions, like if I move, you might see that it kind of bounces on the edge a little bit more aggressively than you might wish. But it's kind of good enough. So it's cutting the corner there, but again, it looks okay. And this is often the case, as I say, you find out that these slightly approximate solutions are often okay. And even if they're not, they're sometimes worth doing if they're easy, because you can use that as like a baseline, and it's up and it's running quickly. And then if you look at it and say, okay, we need to finesse this, then you can do that. But it can be very useful to just get the basic thing going, especially if you're like working on like a real project where you need to get this bit working so some other guy can go and do what he needs to do. So sometimes there's a case for like doing a quick approximate solution to something just to unblock dependencies, and then you maybe go back and improve it if you feel that it's warranted. All right. Okay, so that's what we've done. We've done a little bit of a cheating collision detection system, and that was adequate. So there's a bit more to say on this, yes, but I think what I will do is I'll take the break here, and I'll do the second half of this starting up in another couple of minutes or so.